today's invocation.
Kami langit, ko'y kung pangit sa ado'y ulan. Ikaw ang nabuhat sa kabigulan. Ikaw ang nabuhat sa kalibutan. Manamang mawalik ka.
Morning and welcome to our webinar once again hosted by the USDP Department of Mechanical Engineering, where we will learn and garner a lot of insights for today. So now we would like to welcome the Dean of the College of Engineering and Architecture, Dr. Israel Baguhin, for his opening remarks.
Hello, good morning, Mr. Riponte. Am I audible?
Yes, sir.
Okay, so good morning to everyone, no? To all the participants and to all the faculties of the Mechanical Engineering Department, most especially to our speaker, no? The lecturer, Dr. Panji Prawashida. Sir, good morning. So it is with great pleasure, no, and enthusiasm that on behalf of the College of Engineering and Architecture, we welcome you all to this momentous event and making this webinar, no, the beginning of a promising partnership between the ITB or the Institute of Technology Bandung of Indonesia and of this university, no, the USTP. So this partnership is more than just an academic link. No, it is a bridge that connects the two institutions, no, for this shared na to nga pursuits of excellence in science, technology, and even as for the innovation and extension, no, in our future endeavor. So as we move forward, no, in this era of rapid technological advancement, no, and this strong international linkages and partnership and cooperation, which aim to tackle, no, the global challenges of today's and tomorrow's needs, no, of the global, in the global perspective, no, sa atong mga technology. So we are especially honored to begin our partnership with this webinar with insights from one of the most respected institutions, no, globally, the ITB, known for its contributions, no, to the field of mechanical engineering. So once again, thank you for this endeavor and welcome, no, Dr. Uh, from Indonesia, Panji Prawishuddha.
Thank you so much, Dr. Baguhin, for that inspiring message. I'm sure our students and guests are now ready to proceed with us and listen to our speaker. So before we proceed to our main session, it is an honor and privilege to introduce our distinguished guest speaker. Dr. Pranji Prawisbuddha is a renowned academic and researcher currently serving under the Faculty of Mechanical and Aerospace Engineering at Institute Technology Bandung, or ITB, Indonesia, one of the most prestigious engineering universities in Southeast Asia. He earned his doctorate in engineering from the Tokyo Institute of Technology in Japan with a focus on environmental science and technology. He also holds a Master of Science in Mechanical Engineering with a perfect 4.0 GPA and a Bachelor of Science in Mechanical Engineering from ITB. Dr. Prawisuda has a deep research interest in sustainable thermomechanical system development, particularly focused on utilizing local needs and resources to produce cleaner, more economical energy solutions. Currently, he is the head of the Mechanical Engineering Bachelor Study Program at ITB and previously led the Thermodynamics Laboratory. His teaching and research experience also extend to Tokyo Tech, and he has served in various national and international engineering initiatives for over 2 decades. His long list of research awards includes studies on renewable energy technologies such as Stirling engines, biomass processing, and hydrothermal systems, many of which were supported by major government grants and industry collaborations. He has also been recognized for his Best Innovation Award and Best Researcher Award by ITB. Beyond academia, he has contributed as an energy expert for the Indonesian Ministry of Public Works, JICA Japan, and several city governments, playing a vital role in projects involving waste to energy systems and sustainable energy policy planning. With such a rich background in mechanical engineering, innovation, and education, we are extremely fortunate to have him with us today. Please join me in warmly welcoming Dr. Pranji Prawisuda.
Thank you very much, Mr. Cesar. Thank you very much for the nice introduction. Thank you very much, Professor Israel Baguin. It is a pleasure for me to know you, and it is my honor to have the guest lecture here in USTP. I think I'm really sorry I haven't been to Philippines yet. Not to state Mindanao, but I have a transit several times in Manila. But nevertheless, I think we are really close, and especially in USTP, you are really close with Kalimantan, with Borneo and Sulawesi, and I believe also some of our language is similar or maybe the same. So if I mistakenly speak in Indonesian, I hope you can forgive me and you can understand my language. So without further ado, I would like to start my presentation. Is it okay? I cannot share the presentation from my side. Okay. It's already open. Thank you. So here goes nothing. Good afternoon. I hope you all have a great day. Please let me introduce myself. My name is Panji Pisuda. So like Mr. Cesar has already introduced me previously, I am now the head of Mechanical Engineering Study Program. And currently, I'm also the acting Vice Dean of Academics in the Faculty of Mechanical Engineering and Aerospace Engineering. So today I would like to share a little bit about our mechanical engineering education. I hope we can have a good discussion and ask any question that you like, especially about mechanical engineering in TV and Indonesia. So I would like to start with our location. Maybe some of you have already been to Indonesia, or maybe to Bali, or maybe to Jakarta, or even maybe to Bandung. So this is our place. You are in the eastern and northern part of Bandung. It's near Jakarta. So approximately about 2 hours flight from Singapore or 1 hour flight from Bali. And we can also drive by car from Jakarta about 2 to 3 hours. Or recently, you can also use the high-speed rail. It took only about 30 minutes from Jakarta to Bandung. So it's quite convenient. And we are also in the or encircling by many mountains. So you can expect maybe it's similar in your place. We have a quite cool atmosphere, approximately about 25 degrees centigrade all year, because we are about 709 meters above sea level. And actually, Bandung is one of the old cities made by the Dutch, and we thrived about 1920s, and it's also the time when Institut Teknologi Bandung was built in the first place. This is our main campus in Bandung, in Ganesha. We also have 3 other campuses. The second one is in Sumedang, Jatinangor. It's the next city next to Bandung. And the third one is in Cirebon. It's in quite far, but approximately about 70 to 100 kilometer to that campus. And then we also have the campus in Jakarta. So mainly for mechanical engineering, we are working in Ganesha campus. And this is what it looks like. When you come to Ganesha campus, you will be welcomed by the gate on the left-hand side. And there is a boulevard there, and we have also the Indonesian pool. We call it Indonesia Tenggelam, sinking Indonesia, because it's inside the pool. And we also have this cultural heritage building of West and East Hall. It was made approximately 100 years ago, so we are still preserving it right now. For the newest part, we also have the energy building on the northern part, and yeah, not so big campus, but it's quite packed. And actually, historically, Institut Teknologi Bandung is established during the Dutch colonialization period, and we become Institut Teknologi Bandung not until March 2nd, 1959. Before that, we are one of the engineering faculty in Indonesian University. So we become the institute ourselves in 1959. And currently we have approximately about 1,500 faculties, about 12 faculties or school. And also we have about 23 or 24,000 students currently, and the intake for the undergraduate is about 5,000 students. For postgraduate master student is about 2,000 students, and for doctoral student about 800 students every year. And we have plenty of programs, including undergraduate, master, and doctoral, of course. But what I want to show you especially is in the Faculty of Mechanical and Aerospace Engineering. So we are especially in the field of technology or in the engineering. So if you take a look at us, most of our field is in the engineering and not so much in social, but we also have the School of Business and Management, and we also have the Faculty of Art and Design. So those 3 are becoming one ITB. And this is our faculty, FTMD in Indonesia, Fakultas Teknik Mesin dan Dirgantara, or Faculty of Mechanical and Aerospace Engineering. If you had time to go to Bandung to ITB, please feel free to visit us in this building in LabTech 2 in the 2nd floor. And for the faculty itself, we already started. I already told you that we start as ITB in 1959, but before that, even before Indonesia gained its independence, we already have the Mechanical Engineering Department in 1941. And it's evolving, starting from only mechanical engineering. So it evolved until we have aerospace engineering, we have material engineering. So currently we are transforming from only mechanical to industrial to aerospace to material, and now become a whole faculty. And inside the faculty itself, approximately about 96 faculties active, and we have 7 research group. And inside the faculty itself, we have about 1,600 student body. Half of that, about 800 students, are mechanical engineering students. So we accept approximately about 400 undergraduate student and 100 of master student. But like I said, about half is mechanical engineering. So these are the students. Maybe if you go to our campus, you will see the student with this jacket. We call it student fraternity or student group. On the left side is for aerospace engineering student fraternity. In the middle is material engineering student fraternity. And on the right side is the mechanical engineering student fraternity. You will know us from the 3 stripes on our jacket. We have three slogan. The first one is study, the second one is solidarity, and the third one is society. So all the 3 aspects of study, solidarity, and society is really important for us as student and in the whole atmosphere. These are the students. Maybe you can also see them during the say the graduation day, or we have this kind of workshop to make our own go-kart on or other race car and other things. On the left side is me during the student time. So it was about in 1990s. We don't have the digital camera, so really sorry for the quality. And on the right side, this is when we won the go-kart competition in national competition of student go-kart. And these are what we do. We usually participate in the ASRE, is the American Society of Heating, Refrigerating, and Air Conditioning Engineer. So every year we participate, and usually we got yeah, 1 or 2 or 3 prizes for that. And we also have this kind of flying robot contest. I think, or I believe you as a student also have this kind of contest. Is our most interest if we can meet and compete as a fellow student in mechanical engineering. And we also have this program of ICAPS. This is a design kind of competition program with the Korean university, and we produce a lot of prototyping for this. And research, this is my lab, by the way. Some of the apparatus are working to treat mostly biomass or other unutilized resources like municipal solid waste and other things. For the research itself, in the Faculty of Mechanical and Aerospace Engineering, we have 6 groups. We have thermal groups, we have fluid groups, structure groups, material group, dynamic and control, flight mechanics and operation, and last but not least, and production group. So these groups are serving the 3 study program: mechanical engineering, process engineering, and material engineering. So it's a kind of mixed situation. Maybe I sometimes teach, or I mostly teach mechanical engineering student, but sometimes I also taught aerospace engineering student, or in several locations I also teach material engineering students. It's becoming a norm here in ITB. And we also participate in the development of sustainable aviation fuel. This one is for flight. I should say that Indonesia, we should thank Philippines also, because our first engineer who built the airplane in Indonesia, Mr. Lutanio, is actually learning in Manila for designing the airplane in Far East Aerospace Technology Institute. I think FEATI in Manila. So we start learning from Philippines, and now we are making our own planes, and I believe we can have the same collaboration later in the future. And really sorry, this is mixed with Indonesian language. Yeah. So the other things is that we made catalyst to convert the crude palm oil from CPO to become diesel. So in Indonesia, we have already had a B30 diesel. That means 30% of the diesel is made from CPO. Now currently we are increased into B35, and who knows, maybe it's not on, but also the airplane will be fueled by the biofuel or from biomass. I think we have the same situation in Philippines and Indonesia. And this is the development of N219 amphibious craft. We believe it's useful for the archipelago country, and also in the Philippines. I think it's the same. It can take off and landing on the water, so it will be convenient for us. And the other research that we are doing is the unmanned vehicle. This is the medium altitude long endurance UAV, and we are already making some prototypes of it. And the other thing is for the rail transportation. The Faculty of Mechanical and Aerospace Engineering also in the development of 220 kilometer per hour of the light smart hybrid train. It will be built in Indonesia. And the other thing is for the agricultural industry, we also have a close relationship with Charon Pokpan. I think this is Thailand company, but it's already multinational, working in many countries. Maybe in Philippines also there is Charon Pokpan. So we develop a mobile corn dryer so that the farmer doesn't need to bring the corn and then dry it in some other far away. They can just send it directly in the truck parking next to their farm. Now, for the mechanical engineering study program itself, this is the competition. I'm not really sure what is happening in USTP for mechanical engineering student, but in Indonesia, we are notorious of having a difficult class, and it's quite difficult to graduate. But I want to show you that it is not so. More than 50% of our students can graduate in 4 years. Some of them can brilliantly graduate before 4 years, and the rest is about 4.5 years, and only about 20% more than 4.5 years. And the average GPA of our student is about 3.3 or 3.4 out of 4. So it's not that difficult, that bad as people would like to think about mechanical engineering student. I would like to hear your comment on this in Philippines. What is happening in Philippines? Is it the same or is it different? Now, of course, one of the biggest reasons why people want to study mechanical engineering is because of the job opportunities. We have, I think, the most largest job opportunities after IT, I think, and the average salary is quite adequate. Sorry, this is for civil engineering. This is for
Recording in
mechanical engineering.
progress.
So this is we compare with other study program, and I believe still in mechanical engineering we still have one of the largest job opportunities available. Why is that? Because it's mechanical engineering. I would like to change some of the letters, not mechanical engineering, but mechanical engineering. That's what we are. I believe the difference or the main difference between mechanical engineering and other study program is that we make, of course, product design also make, but we make something that is that can be replicated. It's mass production. It's with high resolution. It's really we calculate the quality. We even calculate how long it can withstand. How long is the lifetime? So that's what make us different. We are mechanical engineering. And for the sectors, I think we can have a quiz here. Most of you, of course, know that the first one is quite famous in mechanical engineering is manufacturing sector. We also have transportation sector, energy sector, process industry, oil and gas, mining, of course, mechanical, and in defense. In defense technology, mechanical engineering is playing the important role. So this is one of the main thing that we need to dig more. But besides that, actually, we also having a good participation or having a good role in construction sector, agro-industry sector, even biomedical sector, ICT, environment and sustainability. This is a new wave of engineering. And also we are usually working in consultation service, education and research like myself, and in finance. Some of my students with the GPA almost 4 came to me and they asked my permission to work in the bank. I said, I cannot hold your dream, so you can pursue your dream. And actually, they are quite thriving in that field. So even in my surprise, they are quite useful. The mechanical engineering knowledge is useful for the finance because we are working in structure. We can see the problem. We can solve the problem in structure, analyze what is the problem, and it is analogous. The same in the finance. And last, usually my student quite surprised about this. We also can participate in tourism sector. When our country become more developed and become a developed country, of course we need to have some refreshing, right? You need to clear your mind after the stress tour. And we believe that the tourism sector will thrive in the future. And as you can see in the figure, mechanical engineers play a pivotal role in designing, constructing, and doing the maintenance. So these are all the sectors that we think is applicable for mechanical engineering, not just in manufacturing, not just in process industry, or not just in energy field, but in many fields. And maybe this is our future. Why? Because we are making a tracer study of our student. The big question is mechanical engineering still relevant? Why is that? Because, the knowledge of internal combustion engine, for example, might not be so developed in the future because electrical car, electrical transportation is right now becoming more and more used in the world. But we still want to know whether our student or our graduates will be able to work. So as you can see in the table, in the right-hand table here, the interesting part is that usually starting from the year of 2018, 2019, 2020, when pandemic occurred, 2021, starting in 2022,